Good morning. Welcome to Space Oddities. Thank you for joining us at this unholy hour for the launch of Blue Ghost to the moon. Joined this morning by the usual suspects: Ian, hello; Daz, hello; Michael, hello.
Hello.
Ian and Daz, I hope you're well. Michael, I know you're not, so hope you're feeling better. Michael's got an absolutely hacking cough, which he's promised not to share with us.
Yeah.
So there we are. So this is quite a very interesting mission to the moon this morning, being launched on a Falcon 9 rocket. Without more ado, what we're going to do is to have a look at the mission itself by way of a video that we've just uploaded to our channel. So this is all about the Blue Ghost mission. Take it away, guys.
Lunar enthusiasts, welcome to our deep dive into America's first lunar lander, headed for the Sea of Crises.
Merecrisium,
that's right.
Yes.
Now we're using an article from astronomy.com for this one.
Excellent.
And I think, we all know a bit about lunar history, but did you know there was almost like a Soviet-American race to get lunar samples back?
Oh, gosh.
And also, did you know that this plane that looks really desolate could unlock secrets about the moon's volcanic past?
Indeed, Merecrisium is a fascinating region.
It is.
Often mistaken, as you say, for just a dark patch on the lunar surface.
Yeah.
It's enormous, actually.
Huge.
It dwarfs Arizona in size.
Wow.
And it's remarkably flat.
Yeah.
And that expanse is composed of dark basaltic plains.
Right.
But within this barrenness, there are signs of past volcanic activity. Sinuous ridges that meander across the landscape.
I see.
Craters that appear to have been inundated by ancient lava flows.
Right.
And Mons Lettre, a lone sentinel rising from the plains.
Okay, so that's why this is a good place to go.
Absolutely a prime target for scientific study.
Yeah, and talking of lunar history, the Soviets actually tried to land there.
They did.
With the Luna missions.
Yes.
Luna 15 actually crashed into a mountain.
Oh.
Luna 23 landed a bit hard and fell over.
Oh, dear.
However, in 1976, Luna 24 successfully returned lunar samples.
It did.
To Earth.
Hmm.
And it really does highlight, the advances in space exploration since then.
Absolutely. And now we've got Firefly Aerospace with the Blue Ghost lander.
That's right.
And this is part of NASA's Commercial Lunar Payload Services program.
Yeah.
And it marks America's first mission to Merecrisium.
It's the first one to go there.
It is.
And it's called Blue Ghost.
Yes.
Which is a clever name because...
Well, it's inspired by the Phausis reticulata firefly.
Right.
It just has a bluish-white glow.
Right, so it evokes the image of the spacecraft landing on the lunar surface.
Precisely.
It's a cool name.
It's okay.
So beyond the cool name, though, what can this thing actually do?
Well, it's actually quite compact,
Right.
But it can carry about 150 kilograms.
That's a lot.
Which is good because it means they can carry a range of instruments.
All the scientific instruments.
And do technology demonstrations.
Right.
That will hopefully lead to some really exciting discoveries.
Groundbreaking discoveries.
Yeah.
The solar panels are pretty good as well, aren't they?
They are. The solar panels are a testament to the advancements in solar technology.
Right.
They can generate enough power to sustain this mission for up to 60 days.
Wow, so 2 months.
Which means a much longer exploration and data collection period than previous missions that had shorter lifespans.
So let's talk about the actual journey to the moon.
Yes.
It starts with a multi-week voyage.
It does.
Which includes an Earth orbit phase where they test everything.
Of course.
Before the final leg, which is the lunar orbit phase.
And then the descent sequence is just a remarkable feat of engineering.
Yeah. How does it work?
So the main engine ignites, propelling Blue Ghost towards its landing site.
Yeah.
And it's all guided by the terrain relative navigation system.
So it's making calculations on the way down.
All the time, adjusting its trajectory, making sure it's going to be safe and accurate.
Why?
And as it gets closer to the surface,
it
does a pitch-over maneuver.
What's that?
Slowing it right down.
To position itself.
Yes.
Okay.
The main engine then cuts off, and 8 reaction control thrusters.
8 of them.
Take over.
Wow.
Guiding the lander down.
For a soft landing.
Precisely confirmed by footpad contact sensors.
That's incredible.
It is a complex procedure.
Yeah, I bet. And of course, the lunar surface isn't exactly predictable, is it?
No, it's not. So to reduce the risks, Firefly have done loads and loads of drop tests on Earth, simulating all kinds of landing conditions. So they've got these shock-absorbing foot pads that they've tested against all sorts of surfaces.
Like what?
Sand, simulated lunar soil.
Oh, wow.
Even concrete.
To make sure it's safe.
To make sure it will be a smooth and safe landing, whatever the terrain.
I see.
And then after touchdown, the real excitement begins.
Okay, what happens then?
14 days on the lunar surface.
14 days. So what are they going to do?
Well, the Southwest Research Institute has provided a magnetometer.
A magnetometer?
Which is a vital instrument.
What does it do?
For understanding the moon's magnetic field.
Right.
And the composition of the mantle.
The mantle.
The layer beneath the crust.
I see.
So it will give us really valuable insights into the moon's formation and evolution.
So Texas Tech University have got an instrument on this too, haven't they?
They have got a drill.
A drill.
To penetrate the lunar surface.
Oh, wow.
And measure heat flow.
And what does that tell us?
This data is critical for understanding the moon's thermal evolution.
Right.
And might be able to help us predict future geological activity.
And it's not just those two, is it? There are others?
There are so many.
So many.
Showcasing the collaborative spirit of space exploration.
Yeah, like the University of Maryland's got that lunar retroreflector.
Yes.
What does that do?
That will allow for really accurate measurements of the Earth-Moon distance.
That's pretty cool.
With implications for all sorts of things.
Like what?
From understanding the lunar interior to probing fundamental questions in physics.
It's incredible, isn't it?
It is. This is just a glimpse of what's planned for Blue Ghost Mission 1.
Yeah.
It's this fantastic symphony of science and technology that's going to reveal so much.
About the moon?
Yes. And its place in the cosmos.
Brilliant.
Blue Ghost Mission 1 is impressive.
It is.
But Firefly Aerospace aren't stopping there.
No.
They've already got plans for Mission 2.
Right.
And even more ambitious endeavors.
Okay.
What they really want to do is land on the far side of the moon.
In 2026.
That's the plan.
Wow. That's
going to be more complicated.
Yeah.
Mainly because of communication challenges.
Yeah, because the far side always faces away from us, doesn't it?
It does.
So there's no direct line of sight.
Which makes communication difficult.
So how are they going to solve that?
Well, they've come up with quite a clever solution.
What is it?
They're going to use the Elytra Dark transfer vehicle.
Right.
That will not only deliver Blue Ghost to the far side, but it will also deploy Europe's lunar Pathfinder satellite, which will act as a communication relay.
I see.
Making sure there's continuous contact between the lander and Earth.
So it's a partnership, really.
It is.
Elytra Dark taking it there, and then lunar Pathfinder helping to communicate.
Precisely.
So what science are they planning to do?
Well, one of the key instruments for Mission 2 is an Australian-built seismometer.
A seismometer?
Yes.
To study what?
The moon's internal structure and seismic activity in a region that hasn't really been explored in this way before.
Wow. So it will add
massively
to our understanding of how the moon formed and evolved.
Absolutely.
So seismic data from the far side, that's amazing.
It is. It opens up all sorts of possibilities.
For lunar science.
Yes. Are there any other experiments planned?
For Mission 2.
Well, NASA are contributing an astrophysics experiment.
What will that involve?
Which will take advantage of the unique radio silence of the far side.
Okay.
So shielded from Earth's radio interference. It's an ideal place to make observations of our early universe, which could unlock secrets about how the cosmos began.
That is amazing. It's interesting, isn't it, how the challenges lead to innovation.
It is.
And often they have implications beyond the mission itself.
Absolutely. The technology that's developed for these missions often has effects across lots of different fields.
Right. Like
developing new materials, propulsion systems, refining communication technologies. It all impacts us back here on Earth.
Yeah, it's easy to forget that sometimes, isn't it?
It is, but we are surrounded by advancements that came about from space exploration.
In our daily lives.
From satellite navigation to medical imaging, new materials, renewable energy technologies.
Right, and now we've got private companies involved.
Yes.
Like Firefly.
Like Firefly, accelerating the pace of innovation.
Yeah.
Pushing the boundaries of what's possible.
And its impact on technology.
Absolutely.
So it really is an exciting time.
It is.
To be following lunar exploration.
Yes, with each mission we learn more.
Yeah.
Our understanding expands.
Yeah.
And we move further into the cosmos.
It's fantastic, isn't it?
It is a testament to human curiosity,
Yeah.
our drive to explore the unknown.
And the moon, which once seemed so distant,
Yes.
it's now tangible frontier.
Is.
And we're only just starting to understand its secrets.
We are.
And as we
Explore
the lunar surface,
That's funny.
I think it gives us a new appreciation for
Where-
where we are
Yes.
in this vast universe.
It's a humbling realization
It is.
that we are not just explorers,
No.
but stewards of this incredible place, our
Yeah.
celestial neighborhood.
And the future of lunar exploration is,
Full of possibilities.
it's exciting, isn't it?
Will we see a permanent presence?
Will we
get a new?
will we unlock the secrets of its resources?
Will we harness those resources for the good of humanity?
It's amazing just thinking about it.
Lunar exploration embodies
It
the spirit of scientific inquiry,
yeah.
technological innovation,
Mhm.
international collaboration.
It does. It's a journey into the unknown.
It is.
And it's driven by our desire for knowledge
yes,
and pushing the boundaries.
of human achievement.
Yeah. And as we move into this new era
Mm-hmm.
with private companies playing a bigger role,
Yes.
what do you think the future holds for international collaboration?
It's a very important question,
It is.
and one that needs careful consideration
Yeah.
as access to space becomes more democratic
Yeah.
with lower launch costs
Right.
and easier technology.
Yeah.
We can expect to see a lot more activity
Yeah.
from a wider range of players.
Yeah.
So in this new landscape,
No.
international collaboration will be more important than ever.
Okay.
We need to have clear framework
For cooperation.
cooperation,
Yes.
for sharing data,
Right.
for how we're going to use resources,
Mhm.
and how we're going to develop this lunar environment peacefully and sustainably.
It's a delicate balance, isn't it?
It is.
We've got to encourage innovation and exploration,
Yes.
but make sure our activities on the moon are conducted responsibly.
And ethically.
Yeah, with that focus on long-term sustainability
Yes.
for everyone.
For all humankind.
Absolutely.
It can't be driven just by curiosity
Right.
or technological ambition.
Right.
It has to be guided by responsibility
To the planet,
to
our species,
future generations.
future generations.
Yeah, so Blue Ghost Mission 1,
Yes,
it really does set a precedent
it does.
for this new era of lunar exploration. It is a testament to what we can achieve through international collaboration,
Yeah.
scientific ingenuity,
Mhm.
and a shared passion for pushing the boundary
Of what we know.
of human knowledge.
And as we look ahead to Mission 2 and beyond,
Yes,
the future of lunar exploration seems very bright.
it does.
It does.
Full of new discoveries,
Yeah.
technological advancements, and a deeper understanding of our place in this cosmos.
Well, as we come to the end of our deep dive into Blue Ghost Mission 1,
Yes,
I think it's clear that we're at a really important moment in lunar exploration.
I agree.
So there we are. So that's a little bit about the Blue Ghost mission. I hope you enjoyed that, viewers. And thank you for joining us this morning. Dan, should we go over to the Cape to see what's going on there? Excuse me. So yes, the emphasis is very much on international cooperation with this year's program of missions launching to the moon. I see now they're looking at launching 18 minutes. So it looks like that's been put back a bit, hasn't it?
Yeah, it looks like 5 minutes difference I got here on the two screens I'm using.
Oh, interesting.
On the other one, I got 13.
Oh,
Uh,
refresh your YouTube.
yeah, that's where I'm just going to go. I'm just going to do it.
We appear to be lagging a few minutes behind. It's worth pointing out as well that there is another lander that's hitching a ride on this particular Falcon rocket, the Japanese Hakuto lander, by a Japanese company that have tried once to land a lander on the moon, but failed, unfortunately. So this is their second attempt. Daz, can you tell us something about the Japanese lander?
Well, basically, the second lander, if you remember, they landed. Excuse me. They landed a lander last year.
Yeah,
But unfortunately, it tipped over. If you remember.
that's right. It fell over.
But it fell over. But this time, what they're doing is they're just sending this this lander. Just excuse me while I just get the details up. Yeah, they're sending this lander. It's on a lander called Hakuto-R. And this is the mission 2, because this, as I said, this is their second lander. They're also on this lander. There is actually a rover, which is 5 kilograms, which is 11 pound, designed and manufactured in Luxembourg, actually. So it's a European lander, which will explore the area around the landing site after being lowered to the surface by the lander. There are other payloads, but unfortunately, I've got no details of what they actually are. But there's about six more different payloads from mostly from Japanese companies. So I'm afraid I can't help you any more than that. But they will be landing.
That's fine. But I mean, Japan is just another country that's got big plans for the moon. China obviously have big plans for the moon as well. So we're going to see a plethora of missions launching to the moon this year. This particular mission with Blue Ghost is part of NASA's commercial payload landings. NASA started this program a few years ago now to encourage private companies to aim for the moon as well. So Blue Ghost is flying under the auspices of that project from NASA to land commercial payloads on the moon. And it's called the CLPS, the Commercial Landing Payload System. And there will be several more missions to the moon this year. I can't remember how many exactly, but we've got a good few missions coming up this year for the moon. So this year looks like it really is going to be the year of the moon in terms of exploration, or looking to the future, or looking eventually to establish a permanent human presence on the moon, which we hope to see in just a few years. The Chinese have announced that they want a permanent presence on the moon, and they're going to land people on the moon by 2030, which is not that far ahead in the future, is it? So
No, not at all. One thing I have just found on here, Andy, it said the little lander will also carry a memory disk developed by the UNESCO organization, carrying 275 languages and other cultural artifacts. So it's going to be sort of like taking a little bit of a sort of, I suppose, a time capsule thing, really.
Yes, and in fact, it's the same as the one that they tried to land on the first mission. So this is a second attempt to put that on the moon as a cultural artifact for future generations. And as I said in the video, we have to think of future generations when it's to what we're doing on the moon. The moon isn't just for us and our generation; it's for our children and their children. So we have to get these things right. We don't want to go doing things on the moon that future generations will look back and say, "Why on earth did you do that? You shouldn't have done that."
If they can pull off the cooperation they're talking about, that'll be brilliant, because that can only be a good thing, obviously.
Absolutely. Yeah. Absolutely. Yes. So there we are. So we're now 8 minutes from countdown over in at the Kennedy Space Center in Florida. And the countdown is progressing. Everything seems to be going well. Michael, do you have any thoughts about this mission?
Just to wish it well. Hope everything goes well.
Me too. Everybody has their fingers crossed here. But then again, this is a Falcon 9, the world's most reliable rocket. So unlike the aborted Blue Glenn launch the other day, we expect a good launch out of this. Don't forget, viewers, that we will be covering the launch of New Glenn tomorrow, the second attempt to launch New Glenn. So, we got some adverts on now. So
that's nice.
Just wanted to say as well, Andy, that it's good that it's launching from the old Apollo launch site.
39A, isn't it?
Yeah.
39A,
yeah. The historic launch pad 39A. There's the control room at Firefly Aerospace. Don't control rooms look so very different these days?
Yeah.
For a start, there's not a haze of cigarette smoke.
There's
No.
not a haze.
Good point.
Yeah.
And apart from the fact that, instead of those enormous consoles that we were used to in the Apollo era,
Oh, yeah.
do you see what else is different there? Something has just struck me.
Lots of women.
I trust
Yeah,
you.
true.
Oh,
I mean,
dear.
simple
Apart from that,
computers and things. Yeah, I don't know.
Well, the
Much smaller.
I don't know.
It's just monitors and keyboards, isn't it?
yeah, but apart from that, have you noticed how young everybody is?
Oh, my God, yeah.
That's the point. Yeah, good point.
In the Apollo days, it was all wizened old men, wasn't it?
It was all in the 50s.
Middle-aged, all aging astronauts and things like that.
And it looks like the vast
I like the way they've got their packed lunches in the corner.
Yeah.
In their rucksacks.
And do you see at top right of the picture? There's a monitor standing there. They're watching Space Oddities.
Yeah.
So that's
And of course, the
They've
thing
tuned
about
in.
this,
That's brilliant.
They know where the best is at.
The thing about this type of mission control, it could be anywhere. It doesn't have to be, in a dedicated room like it was in the Apollo days.
Yeah, that's right. And of course, that one is in a TV studio.
Yeah.
Yeah, it's not real, is it? It's all
CGI.
Just something else I found out about the Japanese lander. The actual rover is called Tenacious.
Not to mention Steve.
So it's only a 5 little kilogram little rover. So so I just thought I'd add that in there. It's called Tenacious.
5 kilograms. Call yourself a rover.
Yeah. Landing mass is 5 kilograms, and launch date. Well, we know the launch date because that's today.
Yeah.
The landing date will be. It says May-June 2025.
Yeah.
Because it's going to do several orbits of the Earth before it leaves, and then it's going to do also several orbits of the Moon before things start to happen as it settles down into an orbit where it will actually deploy the lanterns. Sorry?
How long does it take to get to the Moon anyway?
Well, it all depends, because some of them they use gravity assist, and they take usually sort of like 10 days to 2 weeks.
Right.
But this one is I think it's going to be powered to an insertion for the Moon. And I think it's day 8 that it'll actually start looking at doing some of the landings, I believe. We'd have to have a look at the schematic again.
Yes, that rings a bell. I think it's over a week.
Yeah.
So we're now,
like I said, it's going to do several loops around the Earth and then several loops around the Moon before it settles down into a stable orbit to deploy the landers.
I see.
But they will be landing separately. They won't be landing at the same time. I see they're retracting the arm.
Yeah. Yes.
See it just moving away.
Well, okay, 3 minutes.
Yeah.
Oh, okay.
Fantastic. So we're looking now at 3 minutes.
Yeah. So.
Do we know where the Japanese lander is landing on the Moon?
It says here Mare Frigoris.
Ah.
Mare Frigoris.
Right.
So we'll have to look that up. Get a Moon Atlas out. Get the RAC guide to the Moon and see where we can find it.
Yeah.
Look for the postcode.
Yeah.
Frigoris.
Yeah.
Yeah, it's the one at the near the North Pole of the Moon.
Oh, right. Oh, so they
go
Frigoris.
The long one on the top.
Mare Frigoris. So the sea of, I don't know what's Frigoris.
Oh, I see. Yeah.
It could I think, is it the cold sea?
Yeah.
The frigid sea, like sort of thing. Yeah.
Yes. Definitely. Yeah.
Yeah. All right, it's 2 minutes before liftoff. Dad, should we have some sound so we can listen to
If
the
you
last
wish, you can have some sound. Let me just get the.
We're joining NASA space flight for the coverage this morning.
Let's have some sound.
Director, they do that van there where they essentially clear out the lines, make sure that there's nothing in them that is completely inert at the time of liftoff. You know, securing the lines essentially.
Yep, there it is. Venting out now the
gas launch closeout, so started.
remaining
There's the call-out.
gas in that T. That water tower leak is normal. Don't don't be scared about that. That's expected. That always happens on 39A.
That's their I'm full sensor.
Yep. It's a very visual indicator that the water tower is indeed full. 60
Next step,
seconds.
startup.
Startup call should come up.
Falcon 9 is in startup.
There it is.
Firefly.
Falcon 9 has taken over the launch countdown. Next thing is the launch director signing off the launch with a go for launch.
LD, go for launch.
There it is.
Adrian, are you go?
Looking good.
Because I'm go. Let's go to the moon.
Yep.
T-minus 30
It's
seconds.
time to go to the moon, indeed. Seconds from now, watch at the bottom of the rocket. There you will see the deluge spool up and the green flash of T-Tab, which will ignite the
T-minus
9
15.
Merlin engine.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go Firefly, go ispace, and go Falcon. Vehicles pitching downrange. Falcon 9, power and telemetry are nominal. Engine chamber pressure is nominal. Vehicle is supersonic.
Take long to go through the top of it.
Max
That
Q.
sound is amazing, isn't it?
Under the mighty thrust of 9 Merlin engines, Falcon 9 gets ready to launch 2 payloads to the moon. Absolutely gorgeous. Wow. Is that ours?
It's gorgeous.
Impact chill.
And SpaceX just stole the stat that I was saving for after liftoff. This was the 100th launch by SpaceX from LC-39A. What an amazing launch.
Wow.
Wonderful so far. Everything looking perfect. We hear the call outs. Everything looking nominal as Falcon 9 ignites the night sky.
Okay, should we kill the sound on that now, Daz, so we can talk
Just a
about
few
this?
more seconds left and the
Okay, so look at that.
And I think of the sound as well. The sound was incredible.
It was. It was.
Aren't they recovering the booster this time? Or do they need the performance?
I think they're returning the booster.
Yeah. They haven't said they're not. Ah, there we are. Separation and ignition.
Right, yeah, good.
We've seen this so many times before, of course, but it never ceases to be thrilling, does it?
No.
So stage separation completed successfully. Ignition of the second stage engine. And Japan and Firefly Aerospace from the US are on their way to the moon. Or will be. Oh, look, stars. The color of that on the right is amazing.
Oh, I see, yeah.
Oh, that's a good shot.
Yeah.
Oh, that's brilliant.
Fairings away. So that's on the right-hand side. We're looking at the first stage returning.
Right.
I believe. Not sure.
I think you're right, yeah.
We almost had a jellyfish then. Look.
Yeah, they're looking to part of a jellyfish there.
Beautiful. Look at that.
But certainly know where to put the cameras anyway, don't they?
Well, this is the thing with SpaceX, isn't it? That you know, they've always given us excellent camera coverage.
Absolutely.
So many other agencies and countries don't do this. If you think of India, they don't do any of that. They fly on animations.
It's all animations, yeah. Just one thing. A conversation I had with somebody, excuse me, the other day. If you look at the nozzle on that stage 2, it's glowing.
Yes.
And people are saying, have asked me, why does it glow when it's so cold in space? Surely it gets cool. Well, of course, it actually gets hot, but it can't dissipate the heat through convection.
No.
Putting the heat out because there's no air in space.
There's no air.
So what it is the way it dissipates the energy, the heat that's actually in the bell, is actually through light. So it's dissipating the heat off of the bell, out of the bell, through light radiation.
Yeah.
So that's how they keep it. It's keeping itself cool. So yes, it is getting hot, but it's not sort of like conducting convection into the air, because there is no air. It's actually the actual light itself is cooling the bell. So one of those bits of useless information you need to know.
That's something you don't think about, though, isn't it? Certainly.
Yeah. But that's how it's dissipating the heat from the bell, is through light radiation. It's the light itself.
That's an amazing sight.
Oh, we are landing on a barge by the looks of it.
Yeah.
Well, we're doing the re-entry burn, it looks like. Sorry, I'm looking at another.
There we are.
Oh, right.
There's the re-entry burn.
And this is how these boosters get sooty.
Yes.
Because what you've got is the actual flame of the engines is actually protecting the booster from the heat of the thing. There's a fantastic view coming up in a second for you, lads. Look at that.
Wow. Amazing.
Yeah. So it's fire fighting fire when it's doing the re-entry burn, but to also keep the engines a little bit cooler, they run them a little rich, so there's more fuel going in that's actually needed. So of course that's why you get the massive sooting effect.
Right.
I see.
That was a fantastic shot of that coming back then.
Yeah. See that again.
Wow. Yes, and of course on the way down the rocket is flying through its own plume, so this is where it picks up the soot. And I think when the Falcon started flying and they started returning the first stage, people were saying, well, why don't they clean the rocket for the next launch? And, Elon must have said, what's the point?
Exactly.
Yeah. Yeah, they were saying
I don't know whether you know this. The last Falcon 9 launch, which I think was yesterday or the day before, has reached a new record for 25 launches.
Yeah, I saw that. Here comes the
which
landing burn.
coincidentally is what is the number of launches that Blue Glenn have quoted for their returning first stage on Blue Origin have quoted for New Glenn that their first stage will last 25 times. So there we are, right, landing of the first stage.
Oh, look at this. Oh, wow.
Here it comes. And it's down.
For them to capture that re-entry of that booster quite so vividly, that barge must be quite close to the coast. I thought it was coming back to where it took off.
No.
Well, no, it wasn't from there, will it?
No, not from the Cape. No.
Was that a normal flight time for that booster, or was it a bit longer than normal? Do you know?
I think it was about right. About 8 minutes.
Yeah.
Yeah, I'd have to look at it, review it again.
Yeah.
Oh, there's a lovely picture of the moon. That's the destination. Sorry, I'm looking at another monitor. Sorry.
Oh yeah.
Wow. And Mare Crisium. Hang on. Let's see if they get back there. If you look sort of almost at the 12 o'clock position or the 1 o'clock position, that nearly circular feature is Mare Crisium, the Sea of Crises, where the Blue Ghost lander will hopefully land okay. Of course, it's a flat plane of lava, dating back to the moon's volcanic period, obviously. But that's where the Blue Ghost is headed.
Yeah, it's one of the newer Mare because it's one of the smoothest. I think the Russians tried to land there a couple of times and failed.
Yes, that's right.
It's one of the smoothest sites, or it looks it. When they get there, you'll see it was not that smooth. But there's some lovely views coming of the because as they were saying, what the thing you can see with the legs is the Blue Ghost, and the little canister that's below it contains the Japanese lander.
Right.
And they will be separated when they get near to the moon.
I'm just thinking all these deniers have got something explaining to do, haven't they, with this? I mean, it's amazing.
It's like everything else. They'll deny anything.
I know.
If you took them up in space, they'd still deny it.
Well, true. Yeah.
There's some people they just won't. They're determined that they're not going to know the facts. Because there was some flat earthers recently who went to the Antarctic and to try and prove that the Earth was flat, but most of them came back convinced that the Earth was round.
Right.
To do that, they used the change of perspective of Orion, saying this is how it works. This is the only way this can happen.
Right.
And more of them came away saying, "Oh, what an idiot I've been. Maybe we did land on the moon."
Penguins had something to say as well.
Yeah. But one of the flat earthers they took down there on camera was obviously worried when he was there, and he said, "Oh, I'm going to have to think about this." But now he's come back and said, "Oh, actually, it doesn't change anything." So,
oh God.
You just can't change their minds. It's the same.
You can't get through to these people. They are beyond reach. They really are.
They're just science deniers. They're not just science. They're physics, maths. It's just you can't do nothing about them. That they've fallen into the trap and they're well and truly caught. But there you go. It's they can believe what they like, and we can believe what we like.
Absolutely.
As long as we can live happily together.
It's not a question of us believing; it's a question of us accepting the evidence.
Yeah, exactly.
Well, yeah.
I often watch these, these ancient astronaut theorists on telly.
Oh, do you?
Honestly, I can only watch it for about 2 minutes, and I'm like, "What are you talking about?" Honestly,
makes you angry, doesn't it?
It really does. It's just terrible.
Yeah,
terrible pseudoscience and nonsense. Just God.
Yeah. Fantastic. Right. Well, we're not quite sure when the payload is going to separate. Anybody got any ideas how long we're going to have to wait for separation?
Well, it's got to do several orbits.
Right.
And then, of course, then it's going to be on the second stage, pushed towards the moon to escape Earth's gravity, and then somewhere along the line, it's going to be dropped off. So it's going to be quite a long while. Yeah, it's going to be long time. Long.
So I think we'll wrap things up for this morning, as nothing much is going to happen for a while.
Good.
So
another faultless SpaceX Falcon 9.
Yeah, brilliant.
Absolutely picture perfect launch and some fantastic images.
So lovely.
Just like to say good morning to Sandra. Sandra, you're up early. Goodness me. Good to see you. Who else have we got?
That's it.
If you're with us, because I know we've got 10 people with us at the moment. So just say say hi in the comments. So when you say hi, just say so please do say hi to us in the chat because we like to know who's here. So there we are. So obviously, Sandra, thank you very much for being with us. We hope you'll come back, see us on a Tuesday soon. You're more than welcome.
Yeah.
So there we are. All right. So from us at Space Oddities, thank you for being with us. A picture perfect launch.
Oh, don't forget tonight, Andy.
I'm not forgetting tonight. I was just about to say tonight is also a very, very important mission. It's the 7th test flight of SpaceX's Starship, and this is going to be an amazing mission. So we hope you'll join us. Launch is scheduled for 2200 UK time. We will be going live at 21:45 UK time. So we hope you'll join us this evening. Also, we hope you'll join us for this time tomorrow morning as well, when we have the second attempt to get Blue Origin's New Glenn rocket into orbit after it failed on Monday. So we hope you can join us for that. It's a busy week for us at Space Oddities, lots of early mornings. But we need to bring you these things, viewers, and we love bringing these things to you. So there we are. So hi, DJ Moody's. Hello from Quebec. I hope it's not too cold for you in Quebec at the moment.
And Arizona.
And Arizona.
Yeah, absolutely.
Yes, hi from Arizona. Lovely to see you.
Hope things are okay in Arizona. Lovely to see you. Thank you for joining us. So we are going to wrap things up right now because the spacecraft is going to do several orbits of the Earth before setting off on the moon, setting off to the moon. So yes, Sandra, we will see you tonight for this, what promises to be an incredible flight of Starship. So we go live at 21:45 UK time, and we hope to see you then. Until then, have a lovely day from all of us at Space Oddities. We will bid you a very good morning. So see you soon. Bye-bye, and thanks for being here.
Bye-bye.
Laters, dude.